In Chapter 12, Segment 4, environmental influences also affect sexual differentiation of the nervous system. It says that sexual dimorphism can be modulated by many different environmental factors such as chemical compositions of the environment and behaviors of other individuals. Bisphenol A, or BPA, is a ubiquitous plastic component that comes from neonatal exposure. It can interfere with the development of adult sexual behaviors and demasculinizes male rats in their emotional behavior. It also acts as a steroid mimic and can be found in products such as drinking bottles, baby toys, and food can liners. Social inputs can alter the sexual differentiation of the nervous system. For example, the development of the SNB system. Newborn rat pups can't urinate or defecate on their own, so the mother must lick the anogenital region of the pups to make a spinal reflex to open the bladder and colon. The mother rats spend more time licking the anogenital regions of male pups than the females. If the mother is unable to smell, she licks the pups less and does not distinguish between male and female. Fewer SNB cells survive the period of birth by males raised by anosmic mothers and receive less anogenital licking. This is an example of social influence because the mother treats a pup differently because he is a male and masculinizes his developing nervous system. Any social influence that alters the individual's future behavior must have exerted a physical effect on the brain. On the female pups, attention from the mother has a different effect. If they were licked frequently as pups, they show enhanced estrogen and oxytocin sensitivity in brain regions associated with maternal behavior. If they were licked less frequently as pups, they are less attentive mothers later on. Humans are at least as sensitive to social influences as rats are. Boys and girls are treated differently even when they are infants. This has some effect on their developing brains and contributes later on to sex differences. In Do Fetal Hormones Masculinize Human Behaviors in Adulthood, it says that men and women are more similar than different on most psychological limitations. Many parts of the brain are different between men and women. For those affected with the AIS, they are normally raised as girls, and they have the XY genotype and infertility, which is discovered at puberty. Those with AIS are normally attracted to men and will try and have a family later on through adoption. For those affected with CAH, they are exposed to androgens before birth. Females with CAH play more like boys than girls and are more likely to be attracted to girls in adulthood. In the Guayvadoses, they are raised as girls but grow a penis at puberty. Also, during adulthood, they are attracted to females and dress as men. Prenatal testosterone may masculinize their brains, so even though they were raised as girls, when they reach puberty, they seek out females. Social influences and assigning oneself to a gender and mimicking roles of that gender are unimportant for later behavior and sexual orientation. Early hormones have no effect, and early androgens may affect the brain and masculinize the child's behavior and predispose later sexual orientation towards females. Cochlear extrophy is a rare medical condition in which XY individuals are born with no penis. There have been cases of gender reassignment surgeries with all different outcomes. 8 of 14 of the girls eventually declared themselves as boys. 5 of the 14 were content with being female, and some 5 of the 14 ended up being attracted to girls. In What Determines a Person's Sexual Orientation, it says that there are 2 classes of possible influence on sexual orientation of humans. One is the social-cultural influences that can instruct developing children about how they should behave when they grow up, and the other is the endogenous factors such as differences in fetal exposure to testosterone. Homosexual behavior is more common in anthropoid primates, apes or monkeys, than in prosimian primates, lemurs and lorises. Postmortem examinations of the PLA in humans was performed by Simon LeVay. He found a nucleus, the third interstitial nucleus of the anterior hypothalamus, or NIH3, that is larger in men than women and larger in heterosexual men than gay men. All but one of the gay men in the study died of AIDS, but the third nucleus could not be due to AIDS pathology. Sexual experiences as an adult affect INAH3 structure so that the smaller nucleus in some gay men may be as a result of being gay, not the cause. Lesbians were more exposed to some fetal androgen than were heterosexual women due to autoacoustic emissions from the ears, patterns of eye blink, and skeletal features. The ratio of the second digit to the fourth digit also indicates lesbians were exposed to greater prenatal androgen. This shows that exposure to fetal androgen increases that a girl will grow up to be gay. The difference between gay and straight men would be in response to prenatal androgen rather than the amount. Social difference states that the more older brothers a boy has, the more of a chance he will grow up to be gay. Older stepbrothers have no effect, but biological brothers sharing the same mother increase the probability of a boy being gay even if they were raised apart. The fraternal birth order effect is seen in boys that are right-handed but not left-handed. Studies of genetics in fruit flies have identified genes that control whether courtship behaviors are directed towards same or opposite sex individuals. There is no evidence of how true this is in humans. About 50% of variability in human sexual orientation is accounted for by genetic factors, leaving ample room for early social influences. Monozygotic twins have the same genes, do not always have the same sexual orientation. There is no reliable way to change sexual orientation.